Assalamu alaikum class. In today's lecture we will see another example of recursion and that is Tower of Hanoi. So what is Tower of Hanoi? I think many of you already know. Tower of Hanoi is a game, a mathematical puzzle, and this game starts by having few discs stacked in increasing order of size. But there are only three towers or three pegs, but the number of discs can vary. What we need to do, we need to move all the discs from one tower to another tower, but there are some rules. Like any other game, we need to follow some rules. Let's name these three towers. The first one is source, the second one is temporary, and the third one is destination. And your objective is to move all the disks from source to destination. However, you can only move one disk at a time. Rule number one is you can only move one disk at a time. Rule number two, you can never stack a larger disk onto a smaller disk. You can use temporary tower uh, to move all the disks from source to destination. Now click on this link and try to solve this puzzle in minimum possible moves. Now I will try to solve this puzzle with three disks. Remember the rule is to move all the disks from source to destination and with minimum possible moves. To win this game I need to use only 7 moves to move all the disks from source to destination. Remember the first tower is source, the second one is temporary or spare, and the third one is destination. Now let's start this game. First, I'm going to move a smaller disk from source to destination. Then I'll move second disk from source to spare. And now I will move a disk from destination to source. I think I have made a wrong move. Let's restart this game. From source to destination. Now from source to spare. From destination to spare. From source to destination. Spare to source, spare to destination, and source to destination. Wow, oh, I have completed this game with 7 possible moves. The puzzle with 3 discs was a piece of cake. Anyone can solve that. But what if when I increase the number of discs? With 4 discs, I need 15 possible moves, and with 5 discs, it becomes more harder to solve with minimum moves. Try to solve this game with 4 discs and 5 discs. For 4 discs, the solution is here on this slide. These are the possible moves that you need to follow. Before moving toward its algorithm, I advise you to solve this puzzle, this game Tower of Hanoi, and try to solve this puzzle with small amount of discs, 3 or 4. Once you master that, you can solve the puzzle with more discs with the following algorithm that I am going to explain in the next slide. So here is the recursive solution of Tower of Hanoi algorithm. So if I need to move 4 disks from tower A or source tower to destination tower, then what should be the solution? Number one, first I need to move the largest disk from source to destination, but the largest disk is at the bottom. So the first task is to move n minus 1 disk from source to spare. First, I am going to move top 3 disks from source to spare, and then I can move the largest disk from source to destination. That is the second move, second statement of my algorithm. And the third step is to move that 3 disks that I have moved from source to spare to destination tower. So that is not possible. We cannot move all the 3 disks from source to spare or all the 3 disks from spare to destination at a time, because we can only move one disk at a time. So line number 1 and line number 3 will be a recursive call. We're going to break the problem into the smaller form, and then we're going to solve that problem recursively. Transferring the top n-1 disk from source to spare tower can again be thought of as a fresh problem and can be solved in the same manner. So once you master solving Tower of Hanoi with 3 disks, you can solve it with any number of disks with the above algorithm. Like any other recursive function, this function also contains one if-else structure. If condition is if number of disk is equal to 1, then that is obvious. You need to move that only one disk from source to destination. You need only one move. This is our noun solution or stopping condition or base case. And else part is a journal part. If number of disk is greater than 1, then we need to solve this algorithm recursively. And notice that there are two recursive call in line 1 and line 3. Move toward disk minus 1, source, spare, destination. First we're going to move n minus 1 disk from source to spare, and then we can move the last disk from source to destination in line 2, and the third line is again to move all the disk that we have moved from source to spare to destination. So these are the three statement in which first one and the last one is a function call. Before solving this algorithm, there is very important point that you need to remember. There are four arguments that we're going to pass through this function. Number one is total number of disks. That can be one, two, three, or four, depending on the problem. The second argument is source. The third argument is destination, and the fourth argument is pair. It doesn't matter what is written at the time of calling the function or the receiving end. Always remember that the first argument will always be a disk. That second argument will always be a source. Doesn't matter if A is passed, B is passed, destination is passed, or so spare is passed. The second argument will always be a source. The third argument will be a destination, and the fourth will be a spare.